Okay, so today we're going to focus on autonomous ODE, which are ODE of the form y prime equals a function of y. Form y prime equals f of y, where the right-hand side doesn't depend on t at all. And we will see a very prominent example called the logistic equation. But for now, the main thing to know for today is the following. So main observation. Just three things. First of all, if our function is positive, so if f of y is positive, then by the differential equation, y prime will be f of y, which is positive, which means y prime is positive. And then from calculus, we know that this means that y is increasing. So just knowing the sign of our function already tells you something about the differential equation, which will be super, super important. And well, similarly, if f is negative, then we can reverse this. So if f of y is negative, then we get y prime is negative, and so y is decreasing. Decreasing. And finally, you may ask, what if f is 0? Then weirdly enough, we will get a solution out of this. So let's say if f of something is 0, so if f of c equals 0 for some c, then it turns out we have constant solutions. Y equals c is a solution. And why is that? Simply because, well, if you take the derivative of a constant, so y prime is c prime, but that is 0 because the derivative of a constant is 0. But we know that 0 is also f of c. And that is the same thing as f of y. And so in particular, y prime is f of y. So y equals c is a solution. So what's the moral of this? In order to study those autonomous differential equations, all we need to figure out is the sign of the right-hand side. If the right-hand side is positive, our function is increasing. If it's negative, our function is decreasing. If it's 0, then our function is constant. And now we will see a very prominent application of this called the logistic equation.